Cool. So Frank, so I guess that was the mindfulness minute. Does anybody have any questions or things you'd like to ask about? I've got like a little thing that I want to talk about, and then let folks. Is anyone still working on the homework?
I am.
Or not? You still are?
Yeah.
Mm-hmm.
Okay, cool. Oh, okay, cool, awesome, that's great. Yeah, cool. So what I was hoping to do today was, and what I kind of want to do just every day for the rest of the semester is provide time in class for consultation and working, because some of this stuff is hard. But I do want to talk a little bit about I want to introduce an idea that will help us understand some stuff next Monday. Does this sound okay?
Mm-hmm.
Yeah. But nobody has anything directly to talk about? Okay, cool. Alrighty, so we know that a Mobius transformation, let's get this up here, and of course the condition that makes it a Mobius transformation and not just a fraction of stuffs is that also holds true. And if you missed that on your quiz, you probably got a point taken off or something like that. And I handed back the quizzes, right? Okay, cool, thanks. So we also know that a Mobius transformation fixes how many points? How many points does a Mobius? One.
1, 2 are all.
1, 2, all the points. Yeah. Cool. When does it fix all points? Let's just review some things. Let's kind of come back to that. What Mobius transformation fixes all points? In other words,
Rotation of like 360 degrees.
yeah, so like kind of like the trivial rotation, right? Yeah. So that's actually, yeah, I guess we could think of that as a different one, but in the end, this is the answer right here. The one that looks just like this. The one that literally is just A is 1, B is 0, and C is 0, and D is 1. Right? So the one that literally looks just like that. That's this critter right here. And we could, as Christian was saying, we could make up, we could have funky looking versions of that, but it's all the same. Because this is just one anyway, right? So what if I have a transformation T that fixes 0 and it also fixes infinity? And I kind of want to talk about this because I want to talk about how we deal with that. I think you have some of that in this homework, is that right? There's like an infinity in one of the, is that right or not?
Yes. No, problem 5 asks what's T of infinity.
Yeah.
And T 0.
Cool. So let's just suppose that this is the case and see what that says about the form of T, because we know that if T fixes all points, it's got to look like this. What happens if those are the 2 points that fix? So let's actually, before we even do this algebraically, let's think about the Riemann sphere. So we've got the Riemann sphere with infinity at the top, and then 0 is, I'm gonna make him light because you can't really see it the way this is theoretically set up here. I'm gonna tweak this drawing here a little bit. So let's see, so it intersects right there, and then that's kind of hard to see like that. Does that kind of look like a ball sitting in the middle of a plane? So what are the ways, what kind of things can we do to this sphere that would just fix 0 and infinity? Remember that video where we had, scaling was lifting this up and down, and translation was moving it left and right? What does rotation do? Spins it, right? What does rotation leave untouched if we only rotate?
The axis.
Yeah, exactly. Yeah, so imagine just right on the axis there. So there's this axis coming through this thing like this. If I just spin around that axis, what remains untouched? 0 and infinity. So what we expect, just in thinking about that, that's why this is such a powerful tool, because we can see that the answer is, if we just want to fix 0 and infinity, don't do anything except spin it. Just spin the ball. So we expect this to just look like a rotation, but let's actually get there a different way. So that's the intuitive way, but let's get there algebraically. So first off, t at 0 equals 0. What does that tell us? I just plug it in here. That means that 0 is equal to a times 0 plus b over c times 0 plus d. So that tells me that b over d is equal to 0. What does that tell me? Camila, what does that tell me? So if I know, sorry, what does that tell me about these numbers? If I know this, what could I say?
B is 0.
B is 0, yeah, exactly. So the only way this could happen is if b is 0. So the fact that if t of 0 equals 0, it must be the case that b equals 0. And in fact, we can make this a double-headed implication that if b is 0, this is 0, this is 0, and so this must be true. So we've got this flow in both directions. We've got an if and only if kind of thing going on there. Does that make sense? Yeah? Okay. So right away we know, let's just make life a little bit better. So now we know that t of z must look like this. Yeah? Okay, cool. All right, now let's go to this other one. So now we also know that t of infinity is equal to infinity. So let's think about what that means. Let's take this guy right here. I've got a times infinity, and this is weird. You probably never had the chance to do something this weird looking. When would that be infinity? This is a heavier question for sure. This is a deeper question for sure. And let's actually maybe answer it in a weird way. When would this not equal infinity?
No, that doesn't work, sorry.
That's all. No sorries. No, all good.
Is it when A and C are not equal to each other?
Yeah. So let's see. So let's take a look here. That's close. It's definitely a relationship between A and C. So that would be part of it. So if A and C are not equal to each other, that's kind of part of it. But what if I had this, Kitra? What if I had A was 1, and then down here I had 1 infinity plus some tiny little thing? What would that actually equal?
1?
That would just be 1, right? Because just think, big, giant number over giant number plus dust, right? Because that d is dust compared to infinity. So it's essentially big ass thing over the same big ass thing. That would be 1. So it's not quite that. Does that make sense?
Would C have to be 0?
Oh, yeah. So if c is 0, and I kill off that bottom infinity, then it can't balance out the top one. And so if I just have this, if I just have this, then it doesn't matter what A and D are, and I'm going to get an infinity out. Now A could be negative, but in the Riemann sphere, there is no negative infinity, right? It's just everything's infinity, and you're just approaching it from the backside here. and getting up there versus the front side. So absolutely, so C equals 0. So this tells me that C has to be 0 so that I can't kind of take a limit of those two things right there. Just have the Z's canceled. Just have A and C, the ratio of those two things, be the only thing that matters. So now we've got, beautiful, nicely done. Eraser.
Oh, it's right here.
Oh, I would not have, yeah,
Sorry.
thank you. No, you don't have to be sorry. Man, in the last class, I hope I hit record. I think I did, right? Because we had the whole like talking about stuffs. In the last class, I screwed up my lecture. So if you were here, you saw it. I had an example. I totally screwed it up. But the worst thing I'm thinking that I did was I beat myself up in front of everybody. I was just like, I felt so bad. I was so embarrassed. And I felt dumb. Because I usually, as Lou pointed out, I usually don't screw up. I usually do a pretty good job of not, you know, roaching up my examples and making mathematical mistakes, but I did. I gave a terrible, I made a mistake and it kind of just made everything very confusing, and I started beating myself up in front of everybody saying, oh, I'm a dummy. And I think that was the real mistake. Just coming down on myself. It's okay to screw up. I was embarrassed more than anything, especially being up, you know, with like all the eyes looking at you. It's easy to do. So anyway, that's not really germane to this problem. So we have C equals 0 and we have B equals 0. So our transformation must look like this. So we have T of Z is AZ over, now the C's dead and I just have that. Yeah. And so that's actually just an A over D times Z. Is that making sense? Is that looking good? Ella, just making sure. Yeah? Cool with that? Yeah, cool. Awesome. And this is just some complex number. So we can just call it, you know, it's a complex number. What I know about a complex number is that I can write it in polar form. Does that make sense? And so here A over D in polar form is just that number. And so now we know that this must be the form of T of Z. So thinking about the things we said before, rotation definitely keeps 0 and infinity fixed, but so does scaling, because scaling's just lifting this ball up and down, and it doesn't move it off that axis. It doesn't change that infinity and 0 are still what they are. So remember, scaling was lifting this up and down. So if my Mobius transform fixes these 2 points, if and only if, so in other words, double-headed arrows, and all this stuff has been double-headed arrows, T of Z equals RE to the I theta Z. In other words, it's just a scaling and a rotation. So T just scales and rotates. You can't have translation in there, or inversion, or like just this dividing by a weird ass thing like that. That something that says, if you have this beast down here, if I had something like this is going to then send infinity to 0. If I had something like that. So if this stuff's in the bottom, that would send infinity to 0, because that's what this does. This sends infinity to 0 and 0 to infinity. So the point of everything that I was just saying here is that, I don't know why I'm just boxing the bottom part. That's the key thing. If you fix 0 and infinity, you're a rotation and a scaling. If you're a rotation and a scaling, you fix 0 and infinity. And that's the only kind of transformation that does that. That's going to be super vital for what we do on Monday. So I would like you to please read with that in mind, because this thing we're going to do on Monday is kind of heavy. So prep yourself, like nurture the soil ahead of time. And please do yourself a huge favor and read, because we're going to talk about the thing called the normal form of Mobius transformation, this is one of the heavier things we've done. So I would ask you to please read section 3.5 as best you can. This literally will be the heaviest thing we've done all semester. So take your time and read through that, and read that very carefully. The thing that I just showed you is the little box, or example 353. So I kind of just worked through that example 353, which is really important for constructing the thing we're going to do on Monday, which is also a really cool thing. And this was one of the things that got me really unmoored when I was preparing for this class, but I'm ready for it now. I actually understand it now, but I did not when I first saw it. So do yourself a favor, read that. That's all really the lecture for today. Let's just work on homework, and I can consult, and if you want to talk about anything, if you're done with the homework, go get ready for the snow. Go practice your licks, whatever. Ooh, what's that? That's cool. That's very fancy. Can I see inside?
Yeah. Point to the side.
Yeah.
That's like,
Why?
whoa, my God. Whoa. I've never seen anything like that. That's amazing.
Mind.
He did just blow my mind.
Why
Yeah.
do you use such thin lead?
I never.
I don't know. Last semester when I was writing up a lot more complex analysis, it's just like finer.
A gentle
That makes
touch.
sense. I have a question.
Yes, ma'am.
You know, what?
Do you think it's something that everybody would want to hear, or
Maybe.
is it like
It's-
you just want me to look at something?
No, yeah, it's about kind of what we're
Cool.
talking about.
Yeah. Let's talk about it as a group.
It's, well, part of problem 5 is asking what are the fixed points of this transformation, what's T of 0, what's T of infinity. I know we're talking about it, but I don't get it. And we've been over it before too.
It's
so
okay.
That's why I didn't want to
That's cool. I appreciate that. So can I see which one you're looking
Yeah.
at, Ella? So sorry. So we're.
find the unique blah blah blah, and then this is like the second.
Oh, okay. So finding the fixed points is the part you're not quite
Yeah.
certain about. Yeah. So let's do an example together. So how about, so the first part, there's like a lot going on in that problem, right? You'll have to construct the transformation. So I'm gonna pick it up from that point, unless
Yeah.
that's something you wanna talk about.
No, I get it, and I have like the composition of the inverse of S and T. I just don't know what to do now. To
Gotcha,
answer the
gotcha.
questions.
Cool, so let's just make up a transformation. Let's say I've got T of Z equals, and I'm gonna make life funky for myself. No, even funkier, worse. I was trying to cop out there and make something, let's see, I got that. I might really regret this. I'm probably gonna regret this, but I'll show you what to do. So to find the fixed points, what you want to do is set T of Z equal to Z and then solve for Z. And that's probably going to involve solving a quadratic.
Oh.
Yeah, and so the good news is I probably won't have to do this all, because I think the quadratic formula is going to be god-awful.
Okay.
But let's just do it anyway. So I set IZ plus 2. The ones in the book are set up to be nice when you do this. Yeah. And then actually, let's actually take another example after this. But what I would do is just cross multiply. Then level this all out, get it to one side. So this is iz plus 2 equals 3z squared minus z. Move it all to one side. So this is minus 1 plus iz, because I'm going to subtract that iz off from over there. Does that look okay? And then minus 2. And now I have the only option, like, factoring that sounds really hard, like impossible. So I'm gonna just go now and say z equals the opposite of b plus or minus the square root of b squared. So, which is negative, but it doesn't matter, I'm gonna square it, right? 1 plus I squared minus 4 times a times c, so plus minus 4 times negative 2 times 3, which is 24. And then over 2a. And so, the ones in the book, this piece will not be as god-awful
Okay,
as it is right here. But that's what you want to do.
okay.
Unless, if the transformation just looks like that, then it's 0 and infinity.
Mm-hmm.
Yeah, other than that, see, what do they look like when they only fix one point? It's when this part is 0. I don't know if I can come up with one off the top of my head that only fixes one point. Oh, yeah, I can. So let's say we had t of z equals just z plus. This is a good thing to keep in mind because I don't know if it shows up in that problem set, but if I have pure translation, then the only thing that's fixed is infinity. And actually even this, I think if I have a linear transformation like this, AC plus B, then T of infinity is some number times infinity plus B, and that's just infinity. And that would be the only fixed point in that one, because 0 gets moved to B. And in fact, if I solve this thing, well, let's see. There might be another one. Let's see what happens. Just kind of try that, right? See what it does. So let's see, that means that B equals Z minus AZ. So that's 1 minus, oh, it does have another one. So I don't know, I didn't make one up that only fixed 1 point, because this fixes 2, because the other fixed point is this guy. Ah, but this is a clue. If A had equaled 1, I couldn't have done that, because I'd be dividing by 0. So this, just pure translation, fixes 1 point. Does that make sense?
Yeah, so
Yeah.
if you're finding T of infinity, you like plug in infinity and see what happens?
Yeah. If you have a bottom on your transform, and you plug in, got a little too soon with the infinity there, and you plug in infinity, T of infinity is just the ratio of those leading coefficients.
Oh.
Because you got, and think, do you see why?
Mm-hmm.
Okay, cool.
Yeah, no, that makes a lot more sense.
Yeah, so that's how you do that.
Okay.
Cool. Hi.
Hi.
I'll come. Is this a consultation?
Just
Cool.
so when composing matrices,
Mm-hmm.
do I do, because matrix multiplication is different no matter which one.
Yeah.
So if I'm doing this, is it this?
This is on
times
the left,
This?
and that's on the right. Yes,
Then
ma'am.
I did it backwards.
Oh, yeah, I made that mistake once myself.